So we're very pleased to have a gentleman by the name of Dave Pellerin. And you can get it straight from the horse's mouth, folks. Security is a #1 concern, obviously, when we talk about cloud services, products, or I should say services like Altium 365. And we're very pleased to have Dave. And you can hear straight from them. He's going to give us a glimpse at some of the sensitive applications that AWS is currently involved in directly, and give you a real sense of what to expect with Altium 365 as it runs on Amazon Web Services. Now, as for Dave himself, he's really quite an interesting person. He's currently working for Amazon, and we have an intro video which we'll play. But interesting enough, Dave is also an accomplished author. He's got 5 books that I'm aware of, all on HDL design best practices, HDL language best practices for programmable logic. And as a matter of fact, Dave is a former employee of Altium. We purchased his company called Accolade Design Automation, and he worked here and stayed on as an employee of Altium for a number of years. So small world, and we're very, very pleased to have him. He's really a fantastic speaker, and he's a really, really sharp person. And with that, we'll play his video, and we'll get to Dave. Thank you very much.
David Pellerin serves as Head of Worldwide Business Development for Hitech Semiconductor at Amazon Web Services. Prior to joining AWS in 2012, Mr. Pellerin had a career in electronic design automation and hardware-accelerated reconfigurable computing. He has experience with digital logic simulation, high-level synthesis, and embedded systems for image, video, and network processing. And he's published 5 Prentice Hall technical books. Please welcome David Pellerin.
Hi, this is Dave Pellerin of Amazon Web Services. And I really appreciate the opportunity to talk to you all today about cloud-based innovation, provide some insights into what we do ourselves at Amazon around collaboration, rapid development of advanced technologies, and share with the audience our thoughts about cloud and the experiences of some of our customers using cloud for rapid innovation in semiconductors and electronics. So first, I want to start off by talking a little bit about Amazon, what we do in terms of electronics, semiconductor design. We actually have design teams globally that do a lot of advanced technology products, including Amazon devices, semiconductor devices, things that we do for the data centers in AWS. I'm briefly going to touch also on our innovation process, our working backwards process, because that helps to understand why we structure ourselves the way we do, how we rapidly innovate to create new and exciting products. And as part of that, I'm going to dig a little bit deeper into collaboration. So how do we at Amazon think about third-party collaboration with our supply chain in particular when we think about advanced technology design, right? Then I'm going to lift it up a bit higher and talk about what are we seeing in the industry? What are customers doing with AWS to accelerate their design and engineering? And then lastly, I'm going to give a broader view of what does semiconductor design, verification, and manufacturing mean for Industry 4.0, for advanced technology products that require very high levels of reliability at low costs. Talk about the entire supply chain and how cloud helps with that. That's a lot to cover in 1 hour, so this should be a fun ride. Let's talk first about Amazon, right? So we think of Amazon as an e-commerce company historically, but actually we're in so many businesses now, including AWS, Amazon Web Services, and certainly other technologies, other businesses that require advanced technologies. So think about Amazon devices, the voice-enabled systems in all of our homes. Think about robotics, right? Think about the data center itself. We have many, many requirements for silicon level and system level innovations in support of Amazon Web Services in our data centers. I'll talk about that in a little more detail. And we use AWS ourselves. We use cloud to make the design and verification and implementation, right, of manufacturing of these systems much more efficient and fast. Well, let's think about the broader electronics industry. There are so many products out there. Many of these today require the highest levels of reliability. Think autonomous vehicles, medical devices require very low power, right? So think about edge devices and sensors and so forth. And increasingly, cloud is used to accelerate simulations, accelerate these verifications, to make sure that products are being brought to market fast and with the highest quality of product. I'm going to talk about some examples of that a bit later. When we think about Amazon then, it's important to think of Amazon not only as an e-commerce company, right, but also as an electronic products company. And we, like many others in the industry, have turned to cloud in order to accelerate our innovation and work more effectively with our supply chain partners. Amazon devices, great example. Many millions of devices have been sold. Of these Alexa-enabled and edge devices that are in our homes that include supply chain partners, right? Silicon partners, board-level partners from around the world, and increasingly are developed internally at Amazon through our Lab 126 team, Amazon Devices. On the silicon side, we also have design teams, for example, doing networking chips, doing server chips for use in the AWS infrastructure. I'm going to talk about that in a bit more detail in a moment. Think about the supply chain, right? Whether it's Amazon or whether it's some other electronic product company, supply chain visibility is becoming an increasingly important topic, and supply chain collaboration in particular. And on the left, this is design and engineering. This is where PCB design comes in. This is where silicon design comes in. If you're doing deep silicon design systems on chip, you have to think about wafer fabrication, chip packaging, assembling onto boards and systems, right, PCBs, and then creating those OEM products that delight our customers, right? And then, of course, the distribution side. And Amazon obviously is an important part of that distribution channel to end consumers. So we care deeply about the supply chain. Thinking now about AWS. So Amazon Web Services is a cloud service. We're currently in 24 global regions with 77 distinct availability zones. Why do customers care about this? So if you're doing advanced system design, PCB design, you're doing chip design, you have, as I just said a moment ago, a deep and complex supply chain, and you likely have partners around the world that you're working with. And so collaboration across that supply chain becomes incredibly important in order to enable that fast innovation, right? And reduce your risk of getting products to market on time. Digging a little bit deeper into AWS, for those who aren't familiar with the service, AWS provides cloud services, as I said, in 24 global regions. Each of those global regions consists of multiple availability zones. There's 77 of those today globally, and we're always expanding. Recently, we announced some additional locations, right? So a second region in Japan, for example, and we continue to add regions over time. And again, this allows you to create local infrastructure. So perhaps if you have latency concerns as to why you couldn't run in a region that's further away from you, the availability of these multiple regions with multiple availability zones means that you can create a highly available service, for example, for design and engineering in one particular region, and then collaborate with your supply chain partners around the world who may be running in other regions. As I said earlier, an AWS region is really a geographical region, and then within each geographical region, you have multiple availability zones. Those availability zones themselves may actually consist of multiple very large data centers. And so there's a very large amount of infrastructure available to you in these global regions. So for example, if you're doing advanced silicon design and you need to do some very large simulations or verifications, you can get access to capacity when you need it. And as I said earlier, you can create a highly available infrastructure by using load balancing, by using multiple availability zones, by segregating data as needed. You can create these highly available and scalable environments in the cloud. Digging a little bit deeper, here's just one example of our Oregon region, US West 2. In this particular region, there are, as I said, at least 3 availability zones. There's actually more of them. And these availability zones are each consisting of multiple large data centers. And these availability zones are spread around that geographic region so that they have enough geographic distance, enough redundancy of power, for example, a network, that if one availability zone suffers some sort of network impact, for example, it won't impact the other availability zones. But they're close enough together so that we have low latency and we can have region-wide services, such as managed databases, for example. So that's when you hear about regions, availability zones, and data centers, that's how they're distinct in the AWS cloud. So why is this important? Well, it's important for a couple of reasons. One, because as a customer, you want access to scale and you want access to highly available services that you can build within a region. But it's also important because it means that we have the need to develop custom hardware solutions in support of this particular kind of architecture so that we can offer our customers at scale with a high level of performance and reliability the services they need at massive scale. So this means we've had to reinvent the stack from the silicon on up, right? So we do silicon design, system on chip design for our servers, networks, routers, storage devices. All of this is custom designed by Amazon for the AWS environment, right down to the silicon. And this is so that we can offer high reliability at the lowest possible cost to our customers and maintain a very high level of security. So we use cloud to do that. And why specifically do we use cloud? Well, we use it so that we can innovate much, much faster, scale up, scale down, right size instances, run massive simulations when necessary, collaborate with our partners. This is very, very important. Whether we're collaborating with a EDA software vendor, an IP provider, external design house, maybe our supply chain partners as well, using cloud allows us to do this in a very secure manner, as I'll touch on in a moment. And this reduces our risk so that we can get to market faster, so that we can hit our schedules, and so that we can, pivot and cancel projects if necessary very quickly, because we're not hung up on a particular kind of infrastructure. Cloud is very flexible, right? I want to share some highlights of Annapurna Labs in particular. So Annapurna Labs is a company that Amazon acquired in about 2015. Now, we already had an internal silicon team based in Austin, Texas. We called them the Silicon Optimizations Group, specifically for developing AWS data center infrastructure. When Annapurna Labs was acquired, they were a fairly traditional silicon company based in Israel, developing advanced node chips for use in networking. We were using their chips at the time as part of our networking stack, the NICs in particular on our servers. And we acquired that team, folded them in, and then began to expand the team into other types of products. But that took time, right? So we brought in Annapurna Labs. They had on-premise infrastructure initially, and then they began to migrate to cloud. First in a hybrid environment where some was running on-premise and some in cloud, and then over time, entirely on cloud. So today, the Annapurna Labs team, which is in Israel, but also in Austin, Texas, and other locations, is now entirely running in cloud, collaborating with their partners in cloud, running everything from front-end simulation and verifications to back-end timing analysis, power analysis. Everything that's needed to do advanced node chip design happens in cloud. And here are some of the recent results from Annapurna Labs' movement to cloud. These are just some of the chips that are developed by this group. On the left, the Graviton2 instances. These are ARM-based servers, very complex systems on chip, 7-nanometer process that are used in our Graviton2-based instances, specifically the M6G, C6G, and R6G instance types. The Inferentia chips, these are deep learning inference chips that are used for acceleration of inference. For example, for TensorFlow, for Caffe, for MXNet, these types of machine learning frameworks on the inference side can benefit from custom hardware, and that's what Inferentia provides. AWS Nitro, these are the networking chips that I mentioned earlier, but they actually do a lot more than networking. They provide hypervisor offload, they provide security, they really help us to harden and accelerate the hypervisor layer in the AWS cloud. Again, these are just examples. The Annapurna Labs chip team is very busy on products in response to customer needs. I want to touch on Nitro a little more. So Nitro, that chipset and that software layer is really what helps to differentiate AWS from other data center infrastructure and other cloud providers. The AWS Nitro environment helps us secure the hypervisor, helps us offload hypervisor control planes into this custom silicon, and provide that accelerated networking. It's a very powerful set of chips. You can read more about the Nitro infrastructure on AWS on Amazon.com, and there are some public reInvent presentations that you can find digging a little bit deeper into these Nitro environments. Again, this is to accelerate our EC2 instances, provide very high performance and high security for our customers in AWS, all based on custom silicon developed within Annapurna Labs. I mentioned the Inferentia chips a few moments ago. Inferentia is an example of how machine learning has become so important to us at Amazon. Machine learning really infuses everything we do today in Amazon, whether it's autonomous robotics that are happening in the data center environment or in drone deliveries in the future, for example, things that we do in personalization on Amazon.com, our logistics area, just walkout technology for Amazon Go. Machine learning is a very important and broad set of technologies within Amazon today. Infuses a lot of what we do. I'll touch on some of that later and how it relates to silicon design. The Inferentia Inf1 instances are part of this, as I said earlier, provides faster throughput and lower cost for machine learning inference, silicon-based environments with a whole set of tools around them. So in summary, Amazon Web Services, global infrastructure, regions, availability zones. You can read more about what I just described at infrastructure.aws on the web, and you'll see an interactive view of the infrastructure, including our global network, our servers, data centers, availability zones. There's much more you can learn on that site. Now I want to pivot and I want to talk a little bit about the innovation process at Amazon. And this relates to how we collaborate across the organization with multiple teams and outside the organization. And there's a peculiar mechanism that we use called the working backwards process. I want to briefly touch on that. It helps to understand the culture of Amazon. And this is a quote from Jeff Bezos in a letter to shareholders some years ago. I thought was very relevant. So invention, from Jeff's perspective, comes in many scales and sizes, but the most radical and transformative of these are to empower others, right? So think about AWS as a way to empower others to build. Airbnb, for example, Pinterest, and many of the products and services that we know and love, iRobot, right? Built on AWS, Netflix built on AWS. So these new and innovative rapid startups are more often than not built on cloud today because you can scale so fast and the services are so flexible, right? And this also applies on the hardware side with what we're doing with AWS IoT, for example. If you're building new connected devices, new services based on connected devices, think about using native cloud services like AWS IoT. So we're really here to help customers and partners build out quickly. Internally, there's some mechanisms that we use to do this more quickly, and also mechanisms that we use with our customers and our partners to innovate quickly and stimulate new thinking. Just in brief summary, the working backwards process really begins with identifying a specific customer requirement. It may be a very specific customer requirement, and crafting a narrative in the form of a future-looking press release to describe what it is we're going to solve for in this particular initiative or this proposed new service. This is how, in fact, all of the services that you've come to know in AWS, and in fact, all of the products at Amazon.com, all of the services, that is, and related services have been generated is through this working backwards process. A really important part of this process is the ability to experiment rapidly, take risks, right? collaborate with third parties in a secure way, develop a new idea, combine quickly with a team, and create a first product to put in front of customers. If they like it, move forward, make it better. If they don't, pivot, do something else, right? It's a very, very important concept at Amazon. And when we work with external customers and we work with partners, we often use the same mechanism to define new products and services, new initiatives more rapidly. So we work backwards from customers. I used the word mechanism before, by the way. We don't talk about processes much internally at Amazon because processes tend to be big and heavyweight. Mechanisms are small, lightweight methods that we use consistently across the organization. The working backwards process is just one of those. Another set of mechanisms is how we think about agile, DevOps, right? Microservices, single-threaded teams, or two pizza teams, as we call them, right? So this is one way that we can structure ourselves for more rapid innovation. I mentioned risk-taking before, right? Very important at Amazon that we have the ability to move fast, even perhaps with partial data, right? We're not quite sure something's going to work. We're not quite sure it's a complete fit for the customer. We're not quite sure that it's strategically the right way to go with Amazon, but we want to move. We want to move fast, maybe with only 70% of data, not wait for 90% or we'll be too slow. And to do this, every time we start an initiative, a new product, a new even consumer product, piece of electronics, we're going to ensure that we've built a way to go back, right? So we think of that as a two-way door. Every decision should be reversible, not impact the customers. Don't pre-announce, for example. Really make sure that we can move fast. And if we're going the wrong direction, quickly pivot and go some other direction. Very important set of tenets and mechanisms at Amazon to enable this rapid innovation. Again, summarizing, experiment a lot, measure what you do, learn from mistakes, be a culture of metrics. That's Amazon in a nutshell. And the reason I talk about this in this session is that it's important to understand how we use cloud to allow us to do this at the silicon level and at the electronic system level. We really do believe the cloud is an enabler for rapid innovation. So let's talk now about collaboration. This is a very important topic for us at Amazon. As developers of advanced systems, as an organization that relies on a deep, complex supply chain, how do we think about collaboration? And more specifically, how do we enable it using cloud? Now, here's some examples of the types of design collaboration or external collaboration I'm referring to here. Just a few examples. Let's say, for example, our silicon teams in Annapurna Labs need to do some IP development with a third party. Maybe it's an IP provider, maybe it is a design services partner, and we don't want to have any issue with security, right? And the domains of control, for example. So we're going to create, for example, a secure chambered environment in cloud temporarily that we can collaborate together with our third-party partner. And that might mean a subset of the data is in there. That means that only a small number of individuals are enabled to be in there. So we use cloud to do that and to do it very quickly and effectively. And external customers are doing this as well. And of course, Altium 365, outstanding example of doing the same thing, collaborating in a secure way using cloud. Other use cases might be working with vendors of EDA tools to evaluate new versions, new technologies, new patches without interrupting our production flows. Or perhaps working with our manufacturing partners, getting some data from the manufacturing environment, for example, to do yield and failure analysis, or to evaluate supply chain issues in a collaborative way. Many use cases for this in cloud. When we think about security in cloud, it's very important in the collaboration environments that we create that we have very fine-grained control. For example, making sure that only the right individuals in the right organizations have access to very specific pieces of intellectual property, or that specific individuals, locked down with, identity and access management, or IP ranges, or multi-factor authentication. Many ways that you can secure who is in there in your environment, and monitor who's in there as well. There's advanced capabilities in cloud for monitoring every access to every piece of data, making sure there's no unusual network traffic, those sorts of things are much easier to do in cloud than they would be in a traditional on-premise environment. And the basic idea of collaboration in this way is least privilege, right? It's a security concept, it's a basic tenet where anyone who's in the environment, anyone who has access to that is given the very minimum of privileges that they need to get their jobs done, right? Very, very important concept. So those examples I mentioned earlier, some of them are illustrated by this diagram here. So think, for example, of the electronics company, whether you're doing system design, you're doing chip design, whether you're Amazon or you're some external customer, you're going to have your own cloud-based environment where your engineers are working, they're developing a new advanced product. Maybe they're doing simulations, verifications. If they're doing chip design, perhaps they're doing PCB layout and so forth. They have their own cloud environment to do this. And the partners that they work with, perhaps they're vendors of software tools, design services partners, supply chain partners, they are also going to have their own cloud-based environments. And across the supply chain, organizations are using cloud effectively for internal use cases. So it's rare today to find an organization that is not comfortable with using cloud from a governance and security posture. Well, collaboration means now we need to work together on something. So let's create, either temporarily or for sustained use, a collaboration chamber on cloud, right? A multi-tenant environment, a place where engineers and perhaps other individuals from different organizations can come in and work together on a subset of intellectual property, a portion of the design, for example, either to make sure that it's manufacturable, to evaluate its yield and failures, or to actually collaboratively develop a piece of intellectual property or a board or a system, right? And again, this is exactly where Altium 365 provides value for board design, system design in a collaborative environment. I want to talk about how you might create this yourself if you're going to create your own environment on cloud. It really starts with your own premise, your own environment. Let's say, for example, you have a lab and you've got some local tools on your local machines and you're doing some PCB design or you're doing some chip design. You'll want to connect that into cloud using something called AWS Direct Connect, or perhaps just using a VPN into cloud. Using AWS Transit Gateway is one option to allow traffic to be from your on-premise environment to be routed to the correct chamber. We use the term first-party design chamber here, and that really means this is your environment. Let's say you're doing a system design, you want to collaborate with some design services partners. You have your first-party chamber that you want to bring those people into, or perhaps you'll want to create a separate chamber that allows you to collaborate in a secure way. Notice that we're using AWS Directory Service and Identity and Access Management. These are AWS services that allow you to reach back into your on-prem directory or to use other methods on the cloud in order to identify and validate specific users of this environment, right? Now, if you're doing large-scale simulations like you might do in chip design, or perhaps you're doing some signal integrity types of runs in the case of board design, you may have some batch jobs to run. And so for that purpose, you may use a scheduler and a compute cluster. You may need a license server, and you'll certainly need shared storage of various sorts. And this is specifically for things like chip design that are very simulation heavy and verification heavy. Creating these design chambers in cloud and scaling them up, scaling them down is a very powerful capability. Building this out a bit more, we now have an internet proxy. So if necessary, this design chamber in cloud could reach out to the internet for specific endpoints. For example, to grab libraries that you might have in some other virtual private cloud, or perhaps to access an API endpoint that's provided by some service that you're going to need to use. But you can lock down and make the access to the internet very, very carefully controlled in these environments on cloud. Or you can remove that capability entirely and have any access to the internet go back through your on-premise environment, right? So that you can use your existing firewalls, your existing rules on-premise for internet access. Building this out more, services like CloudTrail and GuardDuty, Inspector, Systems Manager, these are services on cloud that allow you to create a high level of governance and security. For example, CloudTrail allows you to log all API calls that are used in cloud. So you could detect, for example, any change in the configuration at the API level, take these logs and analyze them with various types of tools. CloudRock is a metrics service. Amazon Macy is a machine learning service to detect any anomalous behavior, for example, on the storage side in your S3 buckets. Again, the idea here is that you can quickly build out, through automation, a very secure environment on a cloud as a first-party design chamber. So now let's think about collaboration, right? That first-party design chamber that I've just described is one of these green boxes now. I've collapsed all this down into one box on the upper left, the first-party chamber. So now let's envision that we've got partners out there that have also created cloud-based chambers, right? They've used similar capabilities for governance and security. They've locked down who can access these. They're reaching back to their on-premise infrastructure as shown here. So these third-party partners might have their own design chamber. You may have your first-party design chamber. Idea now is that we want to use the same mechanisms to create a collaboration chamber, right? So that we can have engineers and test engineers from the first party, right, and from the collaborating third party come together in a safe, secure place. And the same idea applies. All of these services now can be used to figure out who's a trusted user, who's a less trusted user, create that environment, and bridge it back to the on-premise world. Bring in a virtual private cloud for the partner, give them a temporary staging place, carefully manage who can come in, who has a partner role in this environment, right? The collaboration chamber. Altium 365 is really a good example of this in the PCB environment. The idea that you can create a collaboration environment in Altium 365 really mirrors what we do ourselves internally at Amazon. We do believe in this deeply as a way to accelerate our innovation through the use of secure third-party collaboration. All right, let's talk now about some of the reasons why we do this internally at Amazon. I mean, I've talked about the need to innovate very quickly. I've talked about our working backwards process, right? But there's a lot of very specific reasons why we do this and the benefits that we're seeing specifically in the chip design area. One of the most important things for us in our silicon design teams is to maintain the security of our intellectual property, our networking chips, our server chips, right? Our Nitro hypervisor chips. So we truly believe by moving these to cloud, AWS cloud, we have been able to have much finer grained control of security and lock down our data, lock down access to, for example, compute clusters on cloud. This is very difficult to do in an on-premise environment, in particular a large EDA installation where you would need to physically create perhaps a caged off environment for collaboration with a third party if you're talking about doing large simulations and verifications with them. Very difficult in an on-premise environment, really quite easy in cloud through automation. This has also allowed us to more rapidly onboard partners. Perhaps we have identified a new intellectual property partner that's got some interesting technology that we might want to incorporate in a system on chip. This allows us to very quickly bring up that environment to evaluate their IP in a secure way and to give them the comfort as well that it's a secure environment. Because again, an IP provider has their intellectual property that they need to preserve. We have our intellectual property. And so using a collaboration chamber like this really helps us with the governance of these types of collaborations and onboardings. But perhaps as important of any of these at Amazon and for external customers is reducing the risk of tape-out schedules. Tape-out meaning when will we get the design done, verified, and ready to turn over to the foundry for fabrication, for packaging, for implementation in a system. And by using scale, using automation, more reliable infrastructure, we feel that we have dramatically increased our ability to deliver on time, and in fact, to deliver faster than we ever could have before cloud. And this allows us to innovate so much faster at Amazon with new products in the data centers, as well as in the consumer devices and Amazon devices. So we learned a lot of lessons along the way. And in fact, we have shared many of these lessons with external customers who are doing system design and engineering, increasingly now using cloud. As I said, onboarding of new partners, much, much faster, more secure. This also allows us to really bring the whole agile and DevOps environment into our silicon design teams and our boards and system design teams. We truly believe that agile, DevOps, continuous integration, CI/CD pipelines, all of these modern software development methods can also be applied to hardware design, and we embrace them, right? We use them. This also, by the way, has helped us to understand our dependencies, because if you're going to take a piece of IP, a subset of your data for a system on chip, for example, and move that to cloud in its own dedicated environment, you'll quickly identify where those dependencies were, because suddenly a file will be missing or a library that's not made available. And so that helps you with governance. If you've done any large chip design, for example, you know that it's very data intensive. Thousands or millions of small files, where are they, right? And so by moving to cloud, having governance, creating secure chambers, locking down IP, you can more quickly identify and resolve those dependencies. Another important thing that we've discovered is cost optimization is important, right? And so making sure that you're scaling up, scaling down, sharing the necessary resources across your virtual private cloud within, of course, the terms of license agreements with EDA software vendors, within the security parameters that you have put in place. Make sure that you're not duplicating data, duplicating compute infrastructure in these different chambers. So we've learned a lot. We have embraced this ourselves, and we're increasingly sharing these best practices with our external customers, some of which you can find in blog posts on the AWS webpage. I want to briefly touch on these governance services. Some of them I mentioned earlier in those architecture diagrams for a secure chamber. But when you do create an environment on cloud, it's important that you take advantage of the services that are available. And there are many, right? So if you want to, for example, bring back your current Active Directory or LDAP infrastructure on-premise for identifying users, there are absolutely ways to connect into that on cloud. There are many, many other services, System Manager, Config, right? These are ways for you to create really enterprise-grade governance and account management capabilities into your environments on cloud. And having fine-grained control of specific services, AWS Service Cloud Catalog, for example, you may have certain trusted users that have a broader access to services on cloud within that chamber, and less trusted users that you want to lock down into a smaller subset of services. These are just some of the things that are available to you in creating a well-governed design and verification environment on cloud, and a collaboration environment on cloud. So control tower, organizations, the well-architected program, there's many, many capabilities on cloud to create secure infrastructure. You'll often hear the term landing zones, by the way, when we talk about this. So if you're creating governance, if you're creating a well-architected environment on cloud for collaboration, think about setting up what we would call a landing zone. There is information about landing zone best practices on aws.amazon.com in the form of white papers, in the form of talks presented at our reInvent conference, and specific services that help you create those guardrails, to create those account level security capabilities, right? So you can identify users, manage them continuously, manage the costs, and operate in a secure, well-architected way. Now I want to pivot and talk about some of the exciting innovations that we're seeing externally from our customers running on AWS. My examples will be biased towards semiconductor design, because that's really where I focus at AWS today, but they're equally applicable in the PCB design world and the system design world. The ability to scale up fast, reduce risk. We're seeing it now again and again at customers running on cloud. And much of this is actually driven by initiatives around smart manufacturing, Industry 4.0. And there are many, many aspects to Industry 4.0 or smart manufacturing that you may have heard of, right? But cloud is really central to all of these. And these are things like digital twin, for example, where simulation doesn't just stop in design and engineering, it continues through the life cycle of the product, right? The use of big data analytics across the supply chain. I'll talk about that very briefly. The use of IoT to manage the manufacturing process, bring that data into cloud. And today, very important areas like AR, VR, so you don't have to physically go into an environment to debug a machine or see what's happening in the manufacturing environment using AR and VR technologies. Autonomous vehicles, all of this enabled today by cloud. I want to talk for a moment about scale, right? If you're doing silicon design or you're doing design of a complex system, like perhaps a disk drive or perhaps a drone, right? The ability to run very, very large amounts of simulations is a game changer for these types of high-tech products, right? And you no longer have to feel constrained. It's no longer absurd to think, well, what could I do if I had 1 million CPU cores for a few hours? What kind of simulations could I run? What kind of innovations could I drive by discovery at that scale? And we do have examples now of customers doing exactly this. And this is so, so important because in the past, before cloud, if you were doing large scale simulations and you had many different projects in flight, I mean, the only truth from an IT perspective was that you always had the wrong number of servers. Either not enough or too many. Not enough meaning you can't get the jobs done fast enough, too many meaning you're spending too much money, right? In the cloud, you can scale up, scale down, and you can do this at an extreme level. Let me give you one example of that. Western Digital. Western Digital does advanced design of storage devices, including hard disk drives and SSDs and so forth. In the hard disk drive area, the increased density of hard disk drives, incredible densities of these devices, require that they do massive simulations of magnetics. These are multi-physics simulations, really, to figure out what the right characteristics of the magnetic materials on the disks are, given the environment that they operate in, right? Helium-filled sealed disk drives running at perhaps 15,000 RPMs with multiple heads flying over the surface. Developing these advanced technology storage devices requires enormous simulations. And Western Digital had a success in 2018 running 1 million virtual CPUs. That's over 500,000 physical CPU cores for one set of simulations, right? Allowing them to finish really in hours, in 8 hours, what otherwise would have taken them 20 days to complete. So a 60x acceleration of their simulations by using cloud and using AWS Spot instances on cloud to make this very cost effective, right? So think big when you think about cloud-based simulations. Now, customers that were doing this in the past, and again, this is the kind of perspective of the silicon design world, they would typically have a shared IT infrastructure for running these simulations and verifications. This is also what you would find in aerospace, financial services. You'd find this kind of environment in the pharmaceutical domain doing proteomic simulations. The idea is that you need a very large number of servers that are shared between different groups in the organization who run these large simulations, typically in a batch environment. So the typical stack on-premise to do this, you would have remote desktop capabilities, you'd have some persistent servers for things like license management and for directory services and so forth. And you would have compute nodes. And these compute nodes, physical infrastructure that are very expensive, and you're using job scheduling software to run the jobs on these environments. And you normally have also shared file storage for these types of environments. It's a typical stack that you would find in a CAE or EDA environment on-premise. Now, when we migrate this to cloud, think about doing this in the context of that collaboration chamber I mentioned earlier. The same kind of architecture, a virtual private cloud within which you have remote desktop capabilities. You have those persistent nodes for things like job schedulers and directory services. You have EC2 instances that can scale up and scale down. And perhaps you're even bringing in some modernization using things like container technologies or serverless approaches, right? And you can also create those shared file system infrastructures if you need them. You can replicate what you normally do on cloud or normally do on premise and move that to cloud. But what's exciting is now once you're in cloud, you begin to deploy a machine learning, analytics, and other services that are available in cloud just to make this better. For example, to analyze the job logs in a simulation run and see if you should use different parameters the next time you make a similar run, so that you're not wasting so much IT resource, you're making better use of EDA licenses, you're getting faster throughput or testing the right corner cases. Machine learning can actually be used for these types of use cases in engineering, and are being used today. If you're not familiar with a silicon design process, it generally looks like this. You've got front-end design. Front-end design means doing things like digital and analog mixed signal simulations, doing some initial synthesis work, getting from a high-level design description down into an actual transistor layout. Back-end design is where you do the more deep floor planning of the chip. You do timing extraction, you do design rule checks, right? As we move into advanced node products, such as our own Inferentia deep learning chip or our Graviton2 chips, this back-end design is actually becoming a very challenging problem. It requires thousands of compute cores for days or even weeks to complete a timing verification or to do a design rule check or some such to prepare that chip for production. And then back in production, there's even more to think about. There's computational lithography, OPC, optical proximity correction. So many workloads that are high performance computing workloads requiring thousands of servers to do a high-end chip, right? MediaTek is a great example of a customer of AWS and also a partner of Amazon who has successfully used cloud to accelerate a 5G cell phone chip. It's a great example of taking some of that back-end compute requirements for static timing analysis, migrating that to cloud so that they could finish in a month and a half the necessary static timing analysis to get that 5G chip to market. This was a TSMC process chip taped out by MediaTek last year. 14 million CPU core hours of static timing analysis on AWS to get that chip from design to manufacturing at the fab. 14 million CPU core hours on AWS for that tape out. Really exciting use case. ARM themselves have been using AWS now to do their design enablements, or specifically to do things like library characterization or digital simulations, moving those to cloud. And they've been very effectively using cloud for some time now. And because ARM processors underlie our Graviton2 instances, it's a really interesting progression now to see that ARM is running on ARM processors on AWS to develop next generation ARM processors, right? So it's a really great partnership we have with ARM. There's more information about that on our AWS Semiconductor and Electronics blog and case studies that we have publicly with ARM about that. But it's another example of taking those large and very compute intensive workloads and moving those to cloud for faster throughput. Astera Labs is an excellent example of a company that's done everything in cloud. So they're a fabless semiconductor company, and they also made a decision to be, if you will, serverless, to not have any on-premise infrastructure of any significance for EDA. It's all running on cloud, and they've been through 2 tapeouts now using full design flow on cloud on AWS. You can read more about Astera Labs on aws.amazon.com. If you move over to the manufacturing side, organizations like Tower Semiconductor and others are now using AWS for smart manufacturing, smart fab. In the case of Tower Semiconductor, their specific problem that they were trying to solve was how to augment human inspection of wafers, silicon wafers, during production of advanced technology chips. And so they use AWS SageMaker and modern serverless design methods to create an environment where camera images of wafers are sent to cloud. When an image of a wafer lands in the cloud, it automatically triggers a service that uses Amazon SageMaker, a machine learning framework, to look for anomalies in that wafer, ring defects, for example, scratches and bubbles and so forth, right? And again, this augments spot human inspection that's done in the production line for higher quality of results and ability to manage their processes for wafer production and wafer inspection, again, using cloud. This you can also read about on aws.amazon.com. So many examples, and this IDEX is an example of a customer using one of our third-party partners to do a design in cloud in a highly collaborative way. They do fingerprint sensors, biometrics, and they use AWS to really accelerate their design. So many examples of this out there today. That was just a small sampling. There are many more examples that you can find on aws.amazon.com about customers doing a design of semiconductor devices, board-level systems, new exciting innovative products that are brought to market through, for example, IoT Core, creating smart connected devices on aws.amazon.com. I wanted to close this out by highlighting the bigger picture, right? And this is a complex diagram. We could have used PCB automatic placement route tools to develop this architecture diagram, but I'm going to quickly walk through it. There's more information about this online at aws.amazon.com. But in the middle, actually in box number 4, that's the design and verification environment. That's the collaboration environment or first-party environment for design that I was talking about earlier, where you had shared file systems, you had clusters, you had the ability to run EDA flows in a batch way. And then below that, collaboration VPC for yield analysis, collaboration VPC for test and regressions, collaboration VPC for manufacturing product feedback. These are all examples of how you might use a collaboration environment on cloud, right? To take data from perhaps the manufacturing process or from the field, from your OEMs, evaluate that data together using a data lake strategy, and augment what's happening on the design side, right? So on the left side, this is more the on-premise environment, whether you are a provider of EDA software tools, you're a provider of intellectual property, you're the first-party developer of a new system, you've got your on-premise infrastructure bridged out to cloud. In the cloud, as I said before, you can create that first-party environment, you can scale it up, maybe even scale it up in an extreme way, as we saw with Western Digital, or create additional smaller locked down collaboration environments for your partners, right? And on the right side of this diagram, this is what's happening in the physical world for manufacturing, for contract assembly, perhaps even for getting data from the field. Maybe you have a smart connected product used in the industrial space, and you're going to get some metrics from that so that you can have predictive maintenance. You can perhaps influence what you do in the next version of the design, or pushing a patch to the machine and so forth, right? Getting that intelligent and secure connectivity up to cloud is very, very important for these next generation connected products. But the key takeaway from this plumbing diagram, if you will, is that data is critical. And analytics is critical. And so within AWS Cloud, you have access to things like Redshift and Athena, Amazon SageMaker and QuickSight, data, AWS Lake Formation. These are all services that you can use to create secure data lakes and analytics platforms that bridge all of this supply chain together. So don't ignore the need to analyze data to build higher quality products and delight your customers in new and exciting ways. It's not just about PCB design. It's not just about silicon design. It's not just about smart factory. It's about bringing all those things together, again, to create the next generation of exciting, intelligent products, secure products, and delight our customers together. So with that, I really want to thank you. I've enjoyed this this time. It's been about an hour, this keynote. The theme here has been innovation. We truly believe that cloud is the driver of innovations today, not only new cloud services, but actual physical devices, smart devices created using innovation methods on the cloud. Take advantage of that unlimited scalability I described before. Take advantage of the fact that you can create secure chambers, collaborate with your suppliers, and create the next amazing product. In Altium 365, again, outstanding product. It's a great way for us to collaborate with our third-party customers as a community. So great congratulations to Altium for building out this product, Altium 365. Look forward to talking to Altium 365 users in the Q&A. So thank you very much. Appreciate the session. Bye now.
Dave, thank you very much. First of all, I would like to congratulate you on that last slide. That is probably one of the most impressive slides I think I've ever seen in my career. It's nice to see you, Dave. You know, it's a small world. Did you ever think that you'd be sort of presenting on behalf of Altium again after many years of absence from when you were an employee when we acquired Accolade?
Well, it's fantastic actually to be back and part of this community. You know, I so much enjoyed that experience and the innovative culture of Altium. So to come back and be part of this community of users is just terrific. So thank you for the opportunity.
No, look, we certainly appreciate having you. And as I said at the outset, you're a fantastic speaker and certainly very knowledgeable on the things you talk about. So we appreciate you taking the time to be with us this morning. With that, we did get some questions that came through as you were giving your keynote. And this is actually, this first question is actually one that came up during my session first thing out of the gate, because we talk a lot about Altium 365 really being accessible from any web-enabled device. And so PCB design obviously kind of heavy when we talk about graphics, 3D graphics, that sort of thing. How does that work with AWS? How do you facilitate that?
Yeah, that's a great question. You know, there are many graphical intensive applications running on cloud, as I think anyone with children and teens in particular know, with massive multiplayer games and so forth. But from the intensity of applications like PCB, you do have to think about latency. And so you'll want to choose an AWS region that's reasonably close to where you are for latency reasons, because we can't really cheat the speed of light. But from the perspective of graphics rendering, you have access to GPUs in the cloud of many types, and then services that lay on top of those GPUs in support of a wide range of graphically intensive applications. So for example, AWS services that are graphic intensive include things like Nice DCV, which is a 3D enabled remote desktop solution that's got a long history actually in 3D graphics rendering for CAE types of applications. AppStream, which is a solution for creating visualizations, if you will, from your graphics applications. And then on the cloud side, of course, we continue to innovate on the GPU side and have newer and different varieties of GPUs on the back end in support of these applications, right? 3D intensive graphical applications, supporting frameworks like OpenGL, right, DirectX and others. Working very closely with NVIDIA, the T4 Tensor GPUs, for example, in cloud, all in support of graphics. So you can expect you'll get excellent graphics performance, and we can do things like helping to mitigate bandwidth limitations, right, through adaptive bandwidth. So lots of things to think about there, but graphics is a very important set of workloads, not just for CAE, PCB, but across the spectrum of cloud-based applications.
Yeah, thanks, Dave, for that. I can also attest to that. If anybody that's used Altium 365 can certainly talk about the silkiness of the 3D rendering that we see. Also, it's probably worth mentioning that the Altium Designer, Altium 365 relationship is that Altium Designer is still running locally with Altium 365 being on AWS. That being said, however, we also are using some of the things you discussed when we talk about GPUs for our virtualized evaluation of Altium Designer today. And I'm here to tell you that the performance is really, really quite good. Now, this next question that came up, actually I learned directly myself the sort of slickness of how easy it is to create one of these VPCs, these virtual private clouds. But maybe you could talk a little bit about that, Dave. Like, how quick and easy and painless is it really to set one of those up?
Yeah, so first let's talk about what a VPC is, a virtual private cloud. It really is a virtual network within which you're going to define your users and roles, what servers, for example, you're going to launch into that, or instances, we call them, and really lock it down. So think of it as, everything that you would do in a traditional data center, from the concrete and the security up and the firewalls and the routers and so forth, done through automation and through software-defined methods, right? And these are audited, validated services that we have, and so you can create highly secure environments. You can do this manually through the console. Take you a few minutes to create one initially, probably a bit more time to do it right and make sure that you got the access controls and so forth in place. But once you've created that VPC, the important thing is that you can capture that configuration using CloudFormation or using other methods, so that you can quickly stand that up in a secure and pre-validated way. And this is super important when you're talking about the collaboration chambers I mentioned earlier. Maybe you want to stand up a VPC in a few minutes, provide access to a small number of users, very tightly controlled. When they're done, freeze it, tear it down, whatever you need to do. But these VPCs, they can be launched in literally minutes with all of the necessary infrastructure to run your workloads.
Well, and I can speak to that as well, because we absolutely are doing that when we talk about our virtualized evaluation of Altium Designer today. On that note, you mentioned security, which is clearly on everybody's mind when we talk about cloud, and we talk about export controlled design data. Are you guys, or do you have examples of people putting that type of information on the cloud?
Oh, absolutely. It's a great question. So there are literally hundreds, perhaps thousands of government agencies and also commercial entities that are dealing with export controlled data, or that have other compliance requirements. But specifically for ITAR, right, for export controlled, we do have a GovCloud region. We actually have two of them now. And the GovCloud regions are US persons only. They allow you to create a compliant environment. Now, as a user of AWS, creating services, placing data, it's a shared responsibility model. You also have to ensure that what you're doing in terms of encryption and access for US persons and so forth, that you are also complying with GovCloud. But we do provide that US persons only export controlled environment for those who need it. And we have many references of this. More information on that actually can be found on aws.amazon.com/govcloud. Lots and lots of information about services in scope, for example, for different levels of compliance with FedRAMP and so forth. So you can find much more information about that on aws.amazon.com/govcloud.
Yes, you said a couple things there, Dave, that actually sort of spurred my memory. I've been talking about, we talk a lot about this morning about the things that our customers are asking for, and we absolutely are pleased to bring those. And then we talk about the sort of pushing towards the transformation of the industry, the sort of next generation of technologies, when we talk about Altium 365. But you're saying that you now have customers that are in fact ITAR compliant, that are using cloud services on AWS.
Oh yes, and for many years. I mean, Aerospace Corporation, for example, years ago had an excellent case study for high performance computing. We have customers across the spectrum of aerospace, defense, as well as government agencies themselves using cloud for advanced design, right? Whether it's design of equipment, design of semiconductors and related systems, and collaborating with their partners in the defense aerospace ecosystem. So yeah, it's a big use case on cloud, very well established.
So that's actually quite interesting to me. Now, you mentioned GovCloud. And what exactly is GovCloud, Dave? That came up actually.
Yeah. GovCloud is it is a specific type of region. So as you may recall, we have 24 regions globally, and those are geographic regions within which there are availability zones that provide infrastructure that you can stand up a highly available infrastructure for design, for example. A GovCloud region is one where we have U.S. persons only managing that. We have been audited by a third party to ensure compliance with export control in terms of how the services are managed, how the data center is managed, and so forth. So using a GovCloud region and then using your own compliance mechanisms, of course, to ensure U.S. persons only having access to your data and so forth, you can create an export controlled ITAR compliant environment on cloud. And as I said, many government and commercial entities that are export controlled use GovCloud today and have been for many years, actually.
Gotcha. Yeah, and I'm definitely familiar with the regions. As when you spin up your workspace with Altium 365, obviously we provide a selection of those regions to our users so they can obviously get the best latency performance depending on where they're located. So one last question I have for you, which is, what is data lake?
Yeah, data lake is a very important concept, in particular for large enterprises that have perhaps even decades of data that they could get value from. Data lake is a common term used to really describe a specific set of technologies around data storage. So imagine, for example, you are a company that's got data from the field, you've got internal data, you have log files from equipment if you're a manufacturer, all kinds of equipment that you could extract value from. So data lake, the idea there is put all of that data in one well-governed place, right, with access controls, encryption, and so forth. Build metadata around that data to help you with queries and searches, but then apply different types of analytics tools to that data. Maybe you're using Hadoop types of analytics. Maybe you're doing traditional data warehousing. Maybe you want to explore machine learning on that data, train some models. Having a data lake strategy makes it possible for you to extract insights across the organization, again, in a carefully controlled way. And on cloud, you have access to tools like AWS Lake Formation. You've got tools on the analytics side, right, for ETL, for doing queries in place on storage, like with S3 Athena and so forth. Machine learning services that are actually becoming easier and easier to use, even if you're not a data scientist. And so these tools, in combination with a very large scalable storage like S3 on AWS, allows you to create these data lake strategies very cost effectively and get insights from data that perhaps you didn't even know was useful data. So the lesson there is don't throw anything away anymore. If you've got data that's coming off machines, you've got data from your engineering environments, you've got data from your customers, stash it away in the data lake. You'll find value from it later, if not today.
So actually, I have one final question, maybe a bit of a selfish question, and that is Amazon putting their money where their mouth is? And so, for example, are you guys designing products like the Echo on the cloud?
Yes, indeed. And I talked about our use of cloud for semiconductor design, but it's certainly true as well. I think I touched on this briefly, that Amazon Devices, our Lab 126 division, also uses cloud quite extensively for design and engineering and to work with our supply chain partners. And this is a very important initiative internally to use cloud to accelerate our design. And in fact, the learnings internally at Amazon Devices in particular, we have captured into an AWS solution. We call it Scale Out Compute on AWS. And this is available as an open source project. It truly is based on the methods for creating a virtual private cloud, for tracking budgets, for scaling up and scaling down compute, again, that are used in Amazon Devices. So Scale Out Compute on AWS. Again, open source project. We can provide a link to that later if you're interested in trying that out and extending it, modifying it, doing what you wish with it.
Well, thank you very much, Dave. That's really the extent of the questions that we saw come through. But I just would like to, again, thank you personally for taking the time to be with us. And again, it's small world, full circle. It's nice to see you back here in your old stopping grounds with us here at Altium. So I do want to thank you very, very much for participating in this keynote this morning.
Hey, thanks for the opportunity. It was really fun.